Welcome to the emissions overview. This is an introduction to aid our understanding of emissions and their effect on our health, climate, and why this topic is important in a world of many competing needs. My name is Tom Coleman. I'm from the Climate Reality Project, Chicago Metro chapter. This is part of a 7-part series where we deal with the emissions overview of this presentation. The next presentation is a summary of solutions, and then 3, 4, and 5 dive deeper into each of the key solutions. And then number 6 would be the electrification pledge. We'll talk about a transition, how we can go from a fossil fuel pledge, which most of us are in, we're in a pledge, and move to an electrification pledge, which breaks us from the fossil fuel pledge. And then number 7 is a very brief summary that tries to bring together all of the key points in all of the other presentations. So the agenda here for this presentation would be the emissions challenge. We'll briefly talk about pollution and greenhouse gas emissions. We'll talk about the sources of these emissions and the consequences of these emissions. Now, so far, our response has been extremely minor compared to the size and the scope of the problem. And we hope to help you understand the size and the scope of the problem so that we can do something. If we don't do something, if we don't understand the problem, then it's pretty hard to spend meaningful time dealing with the problem, which is the challenge we have. We don't have enough people dealing with the problem. So the first would be, why should the typical American worried about holding on to their job, providing for their family, and a million mundane challenges get invested in protecting the environment? We hope to talk about these things in this presentation. And though, to add to the previous slide, after decades of scientific reports and widespread activism, nearly half of Americans in a recent Pew Research poll said they didn't view climate change as a major threat. Now, most people in surveys say that climate change is a problem, but 56% of people said they thought they were already doing enough, maybe too much. So we do have a disconnect on understanding the threat and the concern about climate change and the fact that we need to do like way more than we're currently doing today. Now, also climate issues are often framed as a choice between jobs and the planet. Often politicians will play against each other on this issue. Well, we can't afford to invest in climate reducing policies and electric cars and all these different types of things. And really, this is a false choice. And we hope in talking about some of the experts here to be able to put that to bed. Ray Dalio is a billionaire investor from Bridgewater Associates. He was on CNN recently, and he spoke about the cost of climate change over a series of several decades, okay, will be, in worldwide, will be about $5 trillion to $10 trillion, whether you do something about climate change or not. Okay, think about that for a second. Now, he breaks it down and says areas to spend money would be mitigation, which is where we should spend most of our money to prevent the problem from getting worse. Number 2 would be adaptation, where we are often spending a lot of money now, today, for example, building seawalls, insulating, New Orleans and other, cities that are near the ocean from damages, from increasing floods and different things like that. And then there's 3 damages from weather events that are increasing pretty rapidly. Now, Ray is saying that if we do not deal with climate change, we're going to spend 5 to 10 trillion. If we deal with climate change, we'll spend 5 to 10 trillion. So it's a question of where we allocate our money to prevent the problem from getting much worse, or we deal with mostly adaptation and damages. Now, the world we'll be in, though, will be much worse if we don't deal with mitigation. So that's the key part of this. Now, Al Gore, former U.S. Vice President and chairman of the Climate Reality Project, talks about dealing with climate change adds jobs as we transition from a fossil fuel economy to a green, clean economy. That's a change in a lot of our machines that cause pollution to other machines that don't cause pollution. And so that creates a boom in industry for the types of movement that we need to have happen. Now, it's a false choice to say that dealing with climate change is an economic mistake, because as Ray says very clearly above, it's going to cost you the same. And I would add that I would think it would cost you more if you don't deal with mitigation. But I'll keep it to what Ray said, that it'll be the same. And then Al Gore speaks about renewables like solar and wind are already providing 86% of all new energy. So the good news is it works. The green works, solar and wind work, and batteries, they work. And then Catherine Hayhoe, climate scientist from the Nature Conservancy, says that we have improved, but we are headed towards 2.5 to 3 degrees Celsius of global heating. And now we're at about 1.1 to 1.2. And we've occasionally hit 1.5 for, I think, 80 days last year, but that's not the average yet. So she's saying we're going to average 2.5 to 3 the way we're going, and that every tenth of a degree of improvement is a major step forward to protect our children and our futures. So to do this, though, when asked what should we do, she says we have to get beyond just simple, recycling and light bulbs and things like that, replacement in our homes. And we have to do things and talk to people about the things we do. So while she was not specific in this CNN interview of Ray and Al and Catherine, we know that moving towards renewable energy and things like that are really the answer. And as we do that, we need to talk to people about that. Now, one kind of pollution that's pretty severe is poisonous type pollution. And according to the American Lung Association, 119.6 million Americans, about 36% of all Americans, live in places with failing levels of pollution. Also, breathing in particle pollution increases the risk of other things like lung cancer and can cause early death from heart attacks, strokes, and emergency room visits. Also, climate change enhances conditions for ozone and fire pollution. And then people of color are 3.7 times more likely than others to live in counties that have 3 failing grades of air pollution. Now, the Lancet, to add to this, the Lancet is saying worldwide, air pollution is now killing 8.7 million people every year, 1/5 of all causes of diseases. Often they talk about the fact that somebody dies of a heart attack or something, but the underlying cause or the catalyst to move that person in the direction towards COPD or whatever it is pollution. Now let's move on to green gas emissions. First, we'll deal with carbon dioxide. Now, carbon dioxide lasts up to 1,000 years, so many hundreds of years, and that's kind of a benchmark. We call that a global warming potential, a GWP of 1. It's about 80% of the atmosphere right now. And in the graph, although it's small on the right-hand side, from 1960, you can see that carbon dioxide has increased pretty dramatically from less than 300 parts per million up to about 421 parts per million over time. And it's going straight up. And then another greenhouse gas would be methane, lasts about 12 to 60 years, and it has a global warming potential of 85 times more powerful than carbon dioxide. Now, methane is what you use in your natural gas in your homes, probably for heating, probably and possibly for gas cooking and water heating and things like that, especially in the Midwest. So natural gas is about 85% methane, if I remember correctly. So whenever it leaks and when it's burned, there's a certain amount of it that is still released. It's 85 times, and it reduces over time to 27 times. Now, by the way, when it dissipates, it turns into carbon dioxide and other chemicals. Now, nitrogen dioxide comes from combustion, like automobiles and things like that, lasts 120 years. It has a GWP of 300. And finally, fluorinated gas is used in refrigeration, air conditioners, and so forth, lasts up to 25,000 years with a GWP of 1,000 to 10,000. So fortunately, fluorinated gases are only about 3%, nitrogen dioxide 6.2. But all of these are important, with carbon dioxide being the leader and methane being right behind it. Now, the greenhouse effect, you can see here, if we picture the Earth, the blue line going around the Earth is the atmosphere. It's like a skin of a peach, and it's only about 60 miles thick. And in this, you can see that the sun beats down, goes right through the atmosphere, and then the sun, the radiation is absorbed by the Earth. Some of it bounces out, and some of it's captured by greenhouse gases called the greenhouse effect and stays within the atmosphere and builds up over time. And that's the problem. Now, in the past, there have been changes in our weather events, and in some cases, there has been too little carbon dioxide, and it'd be cold. And today, if we didn't have carbon dioxide in the atmosphere, we'd be probably freezing to death. But too much carbon dioxide is our problem, not too little right now. And we have really way too much. So we're spewing about 162 million tons of man-made global warming pollution into the thin shell of our atmosphere about every 24 hours as if it were an open sewer. And if we take a look at this graph here, let's look at the black line first. If we go back to about 1850, about 290 parts per million, doesn't sound like a lot, but it really matters a lot. And you can see that it has increased over time. Now, at about 1930, we reached a level of 300 parts per million, which is the first time this has happened in 350,000 years. Now, scientists know that because what they can do is they drill ice cores in Antarctica and Greenland, and they can pull up, and they know by plants that are found in the cores and the bubbles of the atmosphere that existed at the time, they know what the atmosphere was like hundreds and thousands of years into the past. So they know around 1930, they knew we hit about 300 parts per million, and they can look back also and understand, and that's how we can say 350,000 years. Now, the immediate impact of that has grown, and around 1980 and 1990, you can see it's really pretty significant, up to 421 parts per million. And you can see the temperature rise on the right side, or right scale on the side, is correlates the temperature rise of the planet in correlation with the greenhouse the CO2 increases, hitting about 1.5 degrees Celsius about 80 days last year. Now, we're not averaging that on a global basis over a long period of time, and that's one of the thresholds that we often talk about. Now, these emissions go into the atmosphere. It's kind of like a tub. They go in, and some of it can dissipate. Some of it comes out, and the dissipation, or the amount that is absorbed by trees and other forms of vegetation, is really a good thing. Unfortunately, the amount we're putting in the atmosphere is so big that the net removals can't keep up. And proof of the fact is the CO2 increasing in the atmosphere over time here. And so you can see here now, if we shift gears from parts per million to how much we're putting into the atmosphere. In other words, parts per million was already in the atmosphere. It's kind of the inventory of what's in the atmosphere. If we look now at our emissions, what we're putting into the atmosphere, we're talking about the black line here, which is our historical emissions up till today. And today is, as we enter 2024, is we are here. And we are here says that we're at about 51 or so gigatons. Now, a gigaton is a billion tons, and a billion metric tons, and a metric ton is about 2,200 pounds. So you can see it's a ginormous amount of emissions that we're putting into the atmosphere, and it needs to go down. It's building up, and it's becoming a serious problem, our temperatures and everything else. And so at the Paris Climate Agreement, we said how we were going to cut our emissions in half, right here, the green line, by 2030, 6 years from today, and that by 2050, we were going to hit net zero, which is about here, which means that the trees in the sinks would be able to absorb a certain amount of emissions to have the equivalent of net zero increases in emission. Now, that's what needs to have happen, and that's what we said in the Paris Climate Agreement needed to happen, and then a further reduction in inventory so that we actually go below zero in a natural state. Now, the predictions from scientists go from actually an improvement. This line, this blue area, doesn't sound like much of an improvement, but it's actually an improvement versus a year or two ago, because of some policies and actions that are being taken, which would have sent us, to 4 or 5 degrees of heating. Now they're saying, well, with current policies, it looks like we'll, may hit 2.9 degrees Celsius or 5.2 degrees Fahrenheit. And then the 2030 targets say, well, if we hit those targets, we'll do better than the policies, and we'll hit 2.5 or 4.5 degrees Fahrenheit of increase. And then the pledges and targets of, gosh, if we can do that, we contain it to about 2.1. And then the most optimistic scenario, if you believe it, says that we could maybe get it down to 1.8 degrees Celsius, which would be under the threshold of 2, which is considered pretty bad. Um, but we really needed to get to 1.5, and that was really the goal. So we're experiencing about 1.1. So you're seeing that 1.5 is looking very risky. Many scientists are saying it's now impossible, and you can see the pledges that we see up here and how bad it really could get. So I wanted you to have a sense of this because a lot of people don't understand. It isn't just what we're putting into the atmosphere; it's what's already there, and then what we're putting into the atmosphere here. It's both of those things that really matter. And the longer we put stuff into the atmosphere, the longer the inventory of carbon or greenhouse gases will build up in the atmosphere. And therefore, the more we'll have to cut later or else. All right, so where's it coming from? You can see the biggest sources would be air transport, oil production, forest burning, land transport, trucks and cars, landfills, industrial agriculture, industrial processes, coal mining and coal plants, and the permafrost, which in northern Alaska, Canada, and in Siberia, frost that's been frozen for thousands of years starting to melt, and it releases methane because of the plant matter that's in there. And that methane is highly flammable, by the way. There've actually been explosions. So that's really a problem because permafrost methane is, what did I say, 84, 80, I think I said plus 80 times that of carbon dioxide when it's released. So that's pretty bad and a big risk. So with that, we'll move on to now looking at the sources a little different way. Let's cut them. Let's be specific about what was on the previous page. Transportation in the US is about 28%. It's from our autos, trucks, and buses and ships, and burning gasoline, kerosene, diesel, electricity, drilling, mining, fracking, digging up coal and burning it to make electricity, industry for things like steel making and cement manufacturing. Agriculture, about 10%. And the beauty of agriculture is if we do regenerative agriculture and we implement agroforestry techniques, that 10% can be wiped out and actually become a sink to help capture emissions from some of these other areas. We have a team, if you're interested in that, working with farmers and farm bills and things like that. And then the last would be the residential and commercial, which would be 13%. And if we redistribute the dirty electricity from over here onto residential and commercial, that 13% probably grows to about 35%. So it's a very significant area like transportation, like energy itself. Now, when we look at these sources of emissions, when we look at fossil fuel sources like oil and gas, coal is about 19% of emissions. For example, the Prairie State Energy Campus in Marissa, Illinois, which supplies about 32 cities such as St. Charles and Naperville with mostly coal power, about 80%, very bad. And then we have Marathon Petroleum in Robinson, Illinois, oil. And then we have natural gas, about 35% from Three Rivers Energy Campus. So these are example of plants like the one in Morris, Illinois here. And the thing that's important is we have to phase away from these things with coal, the most important thing to phase away from. And the way to do that is to stop burning it, okay? Because about 10% of the emissions come from these plants and about 90% comes from when we burn their products. Now, I know a lot of people don't know that, but it's important to understand that factor here. It isn't just these plants that have high amounts of emissions. It's what we do with their gasoline and so forth. So the stop burning fossil fuels is a key mantra for what we need to do. Now, the impact of this is 21 out of the 22 hottest years on record have occurred since 2002, and then the hottest of all have been in the last 9 years. And 2023, scientists say, will be added to this list. Another thing that's important is the ocean heat, not just the air, but the ocean heat, where 50% of the heat in the ocean has happened in the last 20 years alone. And guess what? One of the charts I covered earlier said the emissions correlation since 1980, 1990, around in the next 20, about 20 or 30 years in the past. So we can see that why is this significant? Because we can see that as the surface down so many feet increases in heat, it tends to create weather events such as hurricanes and tornadoes. Now, what's the impact, the cost impact of all of this? Now, the fact is, billion dollar severe storms are on the rise big time. This shows the number of events each year. And while it does vary, you can see the trend line here. The trend line is going in the wrong direction. And also at the same time, because of the rising seas, when water heats up, like I said in the previous chart, when it heats up, it expands, it gets bigger. So what happens is there's now more flooding as the sea levels start to rise as it warms, and then we have more high tide flood days. Now I want to add to the chart on the left, 2023, and there it is. So 2023 is about double 2022 and 2021 in terms of the number of billion-dollar severe storms. Clearly serious. We don't know what 2024 and beyond looks like. We do know that carbon dioxide and greenhouse gases are escalating really bad. So the likelihood is, 2024 and beyond may not be as bad as 2023, but they are probably not going to be as good as 2022. Let me put it this way. And the results of all of this would be the tornadoes and hurricanes, the rising oceans, the floods, the famine, the drought, and the fires. This puts a picture of what was on the previous page, and and the impact of this is long term because, as I said, when the emissions get into the atmosphere, it takes thousands of years for carbon dioxide, or at least 1,000 years, for it to dissipate. So we get into a situation where, as we look to the future, it's really the impact on our children. What happens when this kid in the picture here, is 20 or 30 years old? What will the world be like if we don't do something? Or what about the increase in asthma that's being caused by climate change? Scientists say that are happening. So let's blow up the picture in the bottom left-hand corner so it's a little bit bigger. And you can see from 2010 to 2020, the number of billion-dollar disasters during that decade were pretty dramatic. And 2000, you can see, was about half that. Now, this doesn't include 2023 or 2022, but it does show a trend that is not a pretty picture. Now, these extreme weather disasters also have cost the global economy $2.5 trillion in the last decade, an increase of $1 trillion. Now, remember Ray Dalio at the beginning of this presentation said $5 to $10 trillion. Okay, so when we think about what Ray said, I think he's very conservative. Because you can see here in the last decade alone, what's happened. It's gone up $1 trillion just in the last decade. What happened? Will it go up 2 trillion in the next decade or what? These extreme weather costs in the United States, $1 trillion over the last 7 years alone. And the Lancet 8 years ago, they said that climate change is a medical emergency. And the World Health Organization said climate change is the single biggest health threat facing humanity. And so we can categorize the types of real costs. They lead to political, military, and societal instability, these problems. And they manifest themselves in food supply issues, drought, floods, contamination. You can see the list there. Water concerns such as scarcity, the quality of the water, rising oceans, diarrheal disease, and things like that. And then we don't know if the global health we do know that climate change experts are saying climate change is causing a global health crisis, but we don't know if it means that pandemics are getting happening more often or more severe. That correlation isn't clear, like COVID-19. However, we do know that vector ecology, insect infestations, and things like that increase the probability of global health issues. And I showed you in some pictures just a minute ago the infrastructure impact of floods, mudslides, and climate refugees. A lot of people are concerned with what's happening at the southern border of the United States right now with immigration. And I don't want to get into this here except to say that we ain't seen anything yet. We ain't seen nothing yet, if you want to put it this way, when those areas that are the warmest in lower Central America and South America, India, in many of the Asian countries, they're going to want to go north. And when they go north, it's going to cause a very significant climate refugee issue. And you can understand that. Now, is this all real? Well, the scientists say it's real. The U.S. National Academy of Sciences says it's real. The American Medical Association says it's real. Lung Association, Meteorological Society, Geophysical Union, Chemical Society, the American Association for the Advancement of Scientists. Go to any one of their website and see what they have to say about climate change. If you're a denier, go and see what they have to say. It's serious, it's real, and we have scientific certainty of that. And our own agencies in the United States, government, including NOAA and NASA in the military, put out a global change research program about every 3 years. One just recently came out, citing the very deep and serious concerns that climate change is causing and will continue to cause for the military and other parts of the agencies. And I've skipped over the one at the top, the IPCC, the Intergovernmental Panel on Climate Change, which is many scientists, well over 100 in the United Nations, that put out reports periodically, and they're pretty severe. And I'll be honest with you, if you look back in time at what they had to say 5 years ago, 10 years ago, it's happening faster than they're saying. So if anything, these scientists tend to be conservative. Many times this occurs because there's peer-reviewed scientists and they don't want to commit to something that's, off the wall or might happen. They want to commit to what they're pretty certain of. And what's happening is this is happening quicker than many of them predict. But there's certainty. In fact, it may be a little humorous that Neil deGrasse Tyson says, I'm often asked whether I believe global warming is believe in it. I now just reply with the question, do you believe in gravity? I mean, it's that obvious, not just to Neil, but to scientists in general, it's that obvious. Now, how obvious? Well, 97% of climate scientists agree that humans are causing global warming and climate change. That's where we are. Now, there's a few scientists, there's 3% or so, that are deniers that are out there. They don't want to accept it. But I'll go with the 97% any day. I hope you do too. So the conclusion of this would be global heating is real, measurable, significant, and anthropogenic, which means it's caused, what's happening now is caused by us. If we go back a million years ago, it's different what happened then. Volcanoes and things like that cause climate change as well, many times. But what's happening now is us, especially over the last 50 years. Higher amounts of these greenhouse gases, the main cause. Global heating is now higher than any time in 125,000 years. Scientists say it's significantly altering the climate, and the emissions are cumulative. If I can get nothing more across to you, that it isn't just our emissions, what we're putting up there, it's accumulating in the atmosphere. The inventory of the atmosphere is getting thicker and thicker, causing a bigger and bigger long-term 1,000-year problem. It's highest in 2 million years, in fact, right now. We may be nearing a climate tipping point where Dr. Hansen back in the 80s spoke about climate change, made some predictions, which largely came true. Recently, he says the tipping point's near. We need to be really careful. This is wicked serious. It's exponential, okay, is what he is saying. Now, other climate scientists like Dr. Mann are less likely to say, they say, well, we respect Dr. Hansen, but we believe it's more linear in terms of its increase. It's not exponential, it's linear. But linear or exponential, it's a serious problem. Most climate experts say tipping points are possible things where many different things, weather events, thawing, permafrost, and all these types of ice shelves falling into the ocean getting bigger because it's getting hotter. All of these things come together and cause a tipping point where we start to lose control. We hope it doesn't happen. We got to start acting quick. Now, number 7 is we're likely to spend about the same amount of money, as I said before, to deal with it or ignore it, but the outcomes will be different. We'll spend the same amount of money, but we can have a choice of our outcome for our children to be a little more positive, or we don't deal with it and we deal with disasters and cleanup. And if we aggressively comply with the science, the Paris Climate Agreement, to get as close as possible to that by cutting emissions in half over the next 6 years, or as best we can, and aggressively achieve net zero by 2050, we can avoid the most tragic and potentially irreversible impacts to society. Now, I know this presentation has been a little depressing, oh my gosh, type things that I'm bringing out. I've tried to bring out the science, the facts, what's really happening, okay, transcending politics and just telling it like it is and what's happening and what the predictions are and what's happened. In future presentations going forward, we'll be talking about positive solutions. We can do something about this problem. Now, it's very likely that we can't quite achieve the Paris Climate Agreement, which is in number 8, because we've kind of not been doing very much since 2015 in comparison to what we needed to do. But at least we know there are positive solutions. We want to get to those positive solutions so that we can make a choice. Do we continue to commit to the fossil fuel industry, or do we realize that the last 5 or 10 years have produced machines and methods, all right, that we can apply today to move to the right side, to instead of allowing the sun to be heating and boiling us, but to have the sun harnessing it for electricity, charging our cars, operating machines in our homes. And that's what we'll talk about in the next series of presentations. And, at this point, you may say, well, can I change the world? Well, what can I do? Well, you should understand that families are contributing about 48 metric tons, 16 metric tons per person. Okay. An average family, 3 people, 10,582 pounds of carbon. That's what you're contributing today. So you're changing the world. You're one of about, I think, 320 million people in the United States contributing 16 metric tons each of us to the problem. Now, what we can do is we can change that. We can stop that right now. And what we do individually, if we share it with others, can influence our communities, okay? Because we're social animals. And when we talk to people, we can take the micro of what we do and affect the macro, our communities. And when we buy different products as a result of decisions we change or we make, like different kinds of cars, et cetera, we start to tell business what it is that we expect from them. And this ripple effect could be very strong. And as Margaret Mead said, never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has changed the world. So we've now completed the first segment, the emissions overview. I hope it set the standard of the problem, the seriousness of the problem, and I hope this helps to motivate you, even though it's a bit depressing, to move on to the solution summary and then 3, 4, 5, 6, and 7 to make commitments to actually make change. I want to thank you very much. This is the Climate Reality Project. Be the change you wish to see in the world.